All right, so let's take a look at the homework. We did these first two together. Is that correct?
No.
We didn't?
No.
Wow. Okay, let's take a look at them. For exercises 1 through 6, a number cube is rolled and the spinner is spun. Does the number cube have any effect on the spinner at all?
No.
Is it going to change the outcome of spinning the spinner? No. So these are independent events. So, what is the probability that you will roll a 1 and then spin an A? Roll a 1 and then spin an A. So the probability of rolling a 1 is on a number cube, there's 1 out of 6 sides, so 1/6. And the probability of spinning an A is 1 out of 4. So 1/6 times 1/4 is 1/24. The answer for number 1 is 1/24.
I got that, but I got like 1/6 and 1/4 and I didn't do that.
But isn't that what we said on our notes the other day? We even highlighted how you find the probability of compound events is multiplying. And it doesn't matter if they're independent or dependent. You always multiply to find the probability of a compound event. All right. The probability of rolling a number cube and getting an odd and then landing on a B. So how many odd numbers are there on a number cube? 3. 3 out of 6, or I could have called that 1/2. And then there's 1B, 1 out of 4. So it's 3/6 times 1/4. And if I called that 1/2, I would have had to simplify here later. That's 3/24, and 3/24 simplifies to 1/8. 3, what's the probability of rolling a prime number and then a D? What are prime numbers on a number cube? Which ones are prime? Is 1 prime?
No.
No. 1 is neither prime nor composite. 2?
Yes.
3?
Yes.
4?
No.
No. 4 is composite. 5?
Yes.
Yes. And 6 is composite. Okay, so there's 3 out of 6 again. So that's half of them, 1/2. And what's the probability of spinning and landing on a D? There's 1 out of 4, so times 1/4. And so again, our answer is 1/8. All right. Yes.
I didn't do the simplifying. The calculator did it for me. Because I just multiplied it and it gave me 1/8. I didn't have to do the 3/24.
Good. So, but you had to know that you had to set. Oh, did you use 3/6 or did you use 1/2 to start with? Okay, good. All right. What is the probability of landing on a number greater than 4 and landing on a C? How many numbers on a number cube are greater than 4?
2.
So 2/6, which is 1/3 times, and then landing on a C is 1 out of 4. So if I multiply that, I get 1/12. Five. What is the probability that you're going to land on a number less than 3 and a consonant? A number less than 3. So how many numbers on a number cube are less than 3?
2.
2/6 or 1/3. And which of these are consonants?
3 of them.
A is a
No.
vowel. B is a.
Constant.
C is a.
Constant.
And D,
Constant.
consonant. So it's 3/4. If I cross simplify, then I get 1 times 1 is 1. 1 times 4 is 4, 1/4. Or I would have gotten 3/12, so that simplifies to 1/4. Or if you had done it on a calculator like Ethan, it would have simplified it for you. All right, any questions about these up here? Is it making a little more sense? Let's look at number 7. Oh, do we need to do this one?
Yes.
Landing on a prime number and a consonant. How many numbers are prime again?
3, 6.
3/6 or 1/2. And then how many of these did we say are consonants?
3, 4.
3/4. Multiply across. 1 times 3 is 3. 2 times 4 is 8. 3/8. 7. What is the probability of spinning this spinner 3 times and getting a vowel each time? So how many different events is that if I spin that spinner 3 times?
3.
It's 3 separate events. So what's the probability that the first time I'm going to land on a vowel?
1/3.
There's 1 out of how many?
1/4.
1/4. So the first time I spin it, there's 1/4 chance. The next time I spin it, there is 1/4 of a chance. And the third time I spin it, there is 1/4 of a chance. Those were all independent events. 1 times 1 is 1 times 1 is 1. 4 times 4 is 16. 16 times 4 is 64. So the most difficult part of that was seeing that it was 3 things that we were going to multiply together. And if I spin it 3 times, that's 3 separate events. Does that make sense? Yes? What is the probability of rolling a number cube 3 times and getting a number less than 3 each time? So on a number cube, how many numbers are less than 3?
2.
2. 2, 6, which is also 1/3 times 1/3. And then the last time I roll it, it is 1/3. 1. 3 times 3 is 9, and 9 times 3 is 27. All right, everybody good with those? Yes? All right. Each spinner at the right is spun. Find each probability. Now, if I spin this spinner once, is that going to affect this spinner?
No.
So are these independent events or dependent events? Independent. Spinning this one doesn't have any effect on that one at all. So, what is the probability first of spinning an A? There's 1A out of how many total outcomes? 5, 1/5. And then what's the probability of spinning a 2?
2, 6.
There's 1, 2 out of 6. 2, 6, or 1/3. Multiply straight across and you get 1/15. All right. Any questions about this section? All right. Let's go down here. There are 3 red, 1 blue, 2 yellow marbles in a bag. Once a marble is selected, it is not replaced. Find each probability. How is this different than the 2 sections above? Eiley? We're not replacing it, so that makes these independent or dependent. Dependent. The second event is dependent on the outcome of the first event. So, what is the probability of first selecting a red, not putting that red marble back, and then getting a yellow? So, how many total marbles are there? 3 plus 1 is 4, plus 2 is 6. There's 6 total marbles. And how many red are there? 3 out of 6 is 1/2. Okay, now I put that red marble to the side. So now how many marbles are in the bag?
5.
There's 5 in the bag. And how many are yellow? 2. Multiply. I'm going to cross simplify first. 1 times 1 is 1. 1 times 5 is 5. 1 out of every 5 times I do both of those things, I should get a red and a yellow. 1 out of every 5. All right, let's look at 14. What's the probability of first choosing a blue, not putting that blue back, and then choosing a yellow. So, how many blues are there? 1 out of 6. Now that blue marble is not in the bag anymore, so how many marbles are in the bag? 5. And how many yellows are there? 2. So I get 2/30ths, and 2/30ths simplifies to 1/15. All right, so do you get the idea of how to do this? Yes. Okay, I'm going to leave this with you. I'm going to collect this on Tuesday for a grade. You need to go back and do the rest of it. Now, do I know the difference between, hey, you spent this time writing down all the right answers? And can I tell the difference that you just wrote down the right answers or you showed the work? I can tell the difference. So if you sat here and wrote the right answers, I'm not upset about that. That's going to help you to know if you're doing it correctly. But when you turn this in on Tuesday for a grade, should I see the work that you did? Yes, just like I showed my work, I should see your work. Is it okay if the calculator simplified the fractions? Yes, I'm okay with that. Are there any questions about what I expect on this paper by Tuesday? No? Okay. All right, let's put it to this. Experience with them to be good at them yet. So we're going to do a little more notes on tree diagrams and take a little more practice. They are important that we understand. So a tree diagram is a branching diagram that shows all possible combinations or what of an event? What do you think? Outcomes. That's the math term. What are the outcomes for spinning this spinner and tossing the coin? What are the outcomes? So we're going to look at that. This is event 1. This is event 1. How many outcomes are there for event 1? There are 4 outcomes. So if this spinning the spinner is event 1, what's flipping this coin?
Event 2.
It is event 2. Are those independent or dependent events? Independent. Spinning this spinner has no effect on flipping this coin. How many outcomes are there on flipping this coin? 2. We're either going to land on heads or tails. All right, so here's some step-by-step notes on how to make a tree diagram. The first thing you're going to do is list the outcomes for the first event. What are the possible outcomes for this first event? What are some, if I spun this, what is one outcome that you see? Alexa, what's one outcome on spinning this spinner? Yellow. What's another outcome? Someone? Red. Another is blue. And the last possible outcome is green. So the first thing we would do when we make a tree diagram is list these outcomes. And then under each outcome, we're going to list the outcomes of the second event. What is the second event? What are the 2 possible outcomes? Heads or tails. All right. So, the outcomes of the first event. Do I want to write the word out or can I just use the first letter?
First one.
I can just use the first letter. We're going to make a sideways tree diagram because they want the outcomes of the first event here. So 1 is yellow, red, blue, and green. Those are the outcomes of the first event. And then what are the outcomes of the second event? So if I spin and get yellow and then I flip a coin, I can either get heads or tails. If I spin and get red, then when I flip the coin, I'm either going to get heads or tails. If I spin and get blue, then when I flip a coin, I'm either going to get heads or tails. And the last one, if I spin and get green, then the next event is either going to be heads or tails. So how many different outcomes are there for these two events? How many outcomes are there? 8. So I can do that by counting the end of my tree diagram. Is there a way I could have gotten there mathematically? The fundamental counting principle says I can multiply the outcomes of one event by the outcomes of the other events. 4 times 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 outcomes. So sometimes I need to make a tree diagram, and sometimes I just need to use the fundamental counting principle. All right, let's make a sample space. Let's list our first possible outcome as yellow and heads. Yellow and heads. The next is yellow and tails. Next is red and heads. And the next is red and tails. Next, blue and heads. Blue and tails. And the last section is green and heads. And then green and tails. All right, so let's do these summary questions right here. We may have already answered them, but let's take a look. How many total outcomes are there for spinning this spinner and tossing a coin? We said there's 8 outcomes. What is the probability of the outcomes spinning a blue and getting tails? So spinning a blue and getting tails. So I can look up here, out of 8 possible outcomes, blue and tails happened 1 time, 1 out of 8. Or I could have set up here, the probability of landing on a blue is 1/4 times 1/2. And I could have said 1/4 times 1/2 equals 1/8. So I could have gotten there mathematically, or I could have looked up here and said there's 8 outcomes, and 1 is blue tails. Do you see how to find the probability both times? Yes? Okay. What is the probability of the outcomes spinning a red or green and getting tails? Red or green and getting tails. So here's a red tails and here's a green tails. So that is 2/8. And should I simplify that?
Yes.
That simplifies to 1/4. All right. Let's do these notes, and then I'll let you try the practice problems. How many outcomes are there for tossing 3 coins? How many different outcomes are there? There's 6 outcomes, right? This one is going to be event 1. This is event 2. And this is event 3. So there's 2 outcomes here, 2 outcomes here, and 2 outcomes here. List the outcomes of the first event. So what are the 2 outcomes of this one? What are the two outcomes of this event? Heads or tails? And the outcomes of this third event? Heads or tails? So let's go back and we'll say there are 6 outcomes. Because I don't think we've answered that question on our paper. Alright, so now we're going to use these outcomes and make a tree diagram. Now this one is going to be a top-down tree diagram. We want to list the outcomes of event 1 over here. So we have heads or tails. Now I go to the second coin, and if I flip it, what are my two outcomes? Heads or tails. So if the first time I flipped and got heads, the second time I'm either going to get heads or tails. And if the first time I flipped and got tails, then the second time I'm either going to get heads or tails. And so here's where it gets a little more complex. So if the first time I rolled heads and the second one I landed on heads, what's going to happen the third time? Heads or tails. So it could be heads, 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 tails. Or it could be heads, tails, then what? Heads or tails. I could land on tails, heads, and then heads. Or heads, or tails, heads, and tails. The last time, tails, tails, heads. Or it could be tails, tails, tails. So, how many different outcomes were there? 1, 2, 3, 4, 5, 6, 7, 8. So is our 6 outcomes right here? What did we find here? We found 8. Why is this not right? Why is there not 6 outcomes? How do we find the outcomes? How many were for event 1? And how many for event 2? And how many for event 3? 2 times 2 is 4. 4 times 2 is 8. So is our 6 outcomes right? Nope. And we proved that down here with our tree diagram. All right, sample space. Here's where we're going to list our 8 different outcomes. H, H, H. And then H, H, T. H, T, H. H, T, T. Are we done with this one? We're done with that side. Now we're going to go T, H, H. Then what? T, H, T. And then T, T, H. And the last one is, yes. See, aren't these fun? They are. Compared to some other things we've done this year. This is kind of fun. All right. So, now let's answer the question. How many total outcomes are there for tossing 3 coins?
8.
8. What's the probability of the outcome? First flip heads, second flip tails, third flip heads. So we're looking for heads, tails, heads. 1 out of 8, so 1/8. Could I have gotten there mathematically if I didn't do this? What's the probability of landing on heads? 1/2. What's the probability of landing on tails?
1/2.
And heads? So 1/2 times 1/2 times 1/2. 1/2 times 1/2 is 1/4. And 1/4 times 1/2 is 1/8. We could have gotten there mathematically as well if we did not have a sample space. What is the probability that all 3 flips will be the same? So we're talking about heads, 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 or tails, tails, tails. What's the probability that either of those 2 things are going to happen? 2/8, which is 1/4. 1 out of every 4 flips should be all heads or all tails. That's our theoretical belief. What's the probability of at least 2 tails? 2 tails. So I see that 1 here, 2, 3, 4. 4 out of 8 or 1/2. 4/8, which also equals 1/2. So 1 out of every 2 times, there should be at least 2 tails, theoretically. Now, if we ran an experiment, would it definitely happen?
No.
No, but the more we run the experiment, the closer we should get to this 1/2 probability. All right. Do you feel like this helped you at all with your understanding? I think it probably was helpful. So, it is 8:50. You've got 25 minutes to work on this practice of making tree diagrams and answering questions, front and back. There's one of these. I think on this one, you don't necessarily need to make the tree diagram. So, I think you can answer the questions mathematically. Because there's 40 different outcomes, so I don't know that you necessarily need to make the tree diagram on this problem. Okay? All right. This will be due, let's see, 25 minutes. All right. This can be due Tuesday as well, but y'all have a lot that's building up. Okay? So, the homework we just went over, I want it Tuesday as well. And then lots of us have not even started those IXL assignments that were due on Monday.
I did.
Yeah, lots of people have started them and are almost done. Lots of people have not even tried one problem on either of those 2 sections.
Wait a minute. Is there a new thing?
No, I'm still talking about DD1 and DD2. It was due Monday, this past Monday.
They were due Monday.
Yeah, they were due this past Monday. No. But if it's not done, then next week the people that aren't done are going to have to come to lunch tutoring and get them done.
Yeah, so it's Tuesday.
All right, questions? You may work in groups of 2 to 3 as long as I see that you are working. Come ask me if you have questions.
Just know I knew